So this section is all about finding derivatives of functions by using shortcuts, essentially, what are called differentiation formulas. And so it's important to keep in mind where all of these are coming from. These are coming from the limit, sort of fast forwarding through the whole thing. So for example, if we've got f of x being, let's say, x squared. Well, let's make it a little bit more complicated. Let's make it a times x squared, where a is just some number. When we go to do this limit, it's always going to look the same. What I mean by that is regardless of what a is, the limit will be based, the derivative will be based on this limit. And as we work through it, now that limit ends up being a times x plus h squared minus a times x squared over h. And then one way you can go about doing this is you expand out this x plus h squared and distribute the a, x squared plus 2a xh plus, if there's an a, plus a h squared minus ax squared divided by h. This a x squared and this ax squared add up to 0, at which point we can factor out an h, 2ax plus ah over h. Those h's divide to 1, h goes to 0 at this point, and what we're left with is 2ax plus a times 0. Okay, so it's just 2ax. Now what that gets us is that we no longer, once we know that this is how it's always going to work, that whatever that a is, we now have a formula for, let's say, the derivative of 2x squared is going to be 4x, because you just take that 2 and you double it and multiply it by an x. The derivative of 9x squared is going to be 18x. You just take that 9 and double it and multiply it by x. That's what this idea of the derivative of ax squared equals 2ax is telling us. Now what we'd like to develop is as general a method as possible, all sorts of different formulas that apply to different situations, but we don't want to have an efficiency about them. So that's what we're going to develop in things like the constant rule, the power rule. And then what we're going to do is if I have this derivative and this derivative, how do I add them together? Or how do I multiply them together and things like that? And that's the product rule. We'll look at quotient rule and all of that. And this is the key idea of differentiation formulas, that being that these limits will always work out a certain way. And so we might as well cut to the chase, fast forward from I want to find the derivative to, all right, well, it will look something like this.